Good morning, students. Last class we discussed the type of or classification of colloids based on the first criteria, that is about the physical state of dispersed phase and the dispersion medium. I think all of you go through that table and you can easily answer the different types, as well as if example is given for a particular system, you can easily tell the corresponding dispersed phase as well as dispersion medium of the given example. Okay? All of you thorough with that? Okay. Then next type of classification, second type of classification is based on the affinity, or interaction, based on the affinity or interaction between dispersed phase and dispersion medium. Based on the interaction between dispersed phase and dispersion medium, these colloids are grouped into two. One is lyophilic salt. Lyophilic salt. Here, strong interaction arises between dispersed phase. Strong interaction arises between dispersed phase and dispersion medium. And the second type is lyophobic salt. Lyophobic salt. Here, weak interaction exists between dispersed phase and dispersion medium. If water acts as the medium, it is called hydrophobic. If in alcoholic medium, it is called alcohophobic, like that. Generally, lyophilic, strong interaction arises between the dispersed phase and medium, and in lyophobic, weak interaction. The interaction is comparatively weak between dispersed phase and the medium. And next we can list the difference between lyophilic and lyophobic salt. Lyophilic salt, lyophobic salt. In lyophilic salt, they are stable. Lyophilic salts are stable. They are not easily coagulated. Coagulation means, blood is a colloidal system. Clotting of blood, normally termed as coagulation or precipitation. Not easily coagulated by the addition of small amount of electrolyte. They are stable, therefore not easily coagulated by the addition of small amount of electrolytes. Here, lyophobic salts are less stable, therefore easily coagulated by the addition of small amount of electrolytes. Less stable. Lyophobic is less stable. They can be easily prepared by mixing or warming with dispersion medium. Lyophobic salt can be easily prepared. Their method of preparation is very easy, either by just mixing or by after mixing followed by warming or heating. For example, in order to prepare starch salt, either you add starch powder directly to hot water or you add starch powder to cold water followed by heating. You get starch salt. While in the case of this lyophobic salt, they require some special method. That is, the preparation of lyophobic salt require certain special methods. Then they are reversible salt. Lyophobic salts are reversible. That is, starch powder is added to hot water. On prolonged heating, water molecules are evaporate or water molecules are expelled. We get starch powder. Again adding hot water, you get starch salt, or starch salt is regenerated by adding hot water. That means in that sense it is reversible in nature, while lyophobic salts are irreversible. They are irreversible. Here about solvation, they are highly solvated. Solvation effect is more in lyophilic salt, while extent of solvation is less. Here surface tension and viscosity are much higher than dispersion medium in the case of lyophilic. Here almost equal or less than that of dispersion medium. And these are the main point, and here you stress this point. What about the stability, or out of lyophilic and lyophobic, which one is less stable? Okay, lyophobic is normally less stable, therefore it easily undergo coagulation. This is the second type of classification of colloid. First classification is based on the physical state. We get 8 groups such as solid salt, aerosol, gel, emulsion, liquid aerosol, solid form and foam. 8 groups are there. Second criteria, on the basis of interaction or affinity between dispersed phase and medium, they are grouped into two. One is lyophilic and other is lyophobic. In lyophilic, strong interaction arises, and in lyophobic, interaction is comparatively weak. And the third criteria for the classification of solid is based on the nature of particle. Based on the nature of particle. Based on the nature of particle, colloids are classified into multimolecular colloids. Multimolecular colloid. Multimolecular colloid means here the particles of dispersed phase combines to form small groups or molecules within colloidal dimension. Dispersed phase aggregate to form atoms or molecules with the colloidal dimension. Example, sulfur salt, gold salt. You know, sulfur, atomicity means number of atoms present in a molecule. Sulfur atom, it has a crown shape or puckered ring structure. S8 molecule, that is S. 8 sulfur atom. One sulfur molecule consists of 8 sulfur atom. It has a crown shape, or it is called a puckered ring structure. That is when it forms colloid. These 8 sulfur atoms aggregate to form colloid. Colloid means their dimension lies in between 1 to 1000 nanometer. That is about multimolecular colloid. Second type is macromolecular colloid. Macromolecular colloid. In macromolecular colloid, the particles of dispersed phase are sufficiently big in size to be of colloidal dimension. The particles of dispersed phase are sufficiently big in size to be of colloidal dimension. They are called macromolecular. I think you are familiar with the term polymers. Here, the common examples for this macromolecular colloid is starch sol, protein sol, starch sol, protein sol, etc. I think you are familiar with the starch. Actually, starch are polymer of glucose. Large number of glucose combines to form starch. In the same way, proteins are polymers of amino acid. Again, one of the biomolecule. Amino acid combines to form protein. Glucose molecule combine. Large number of glucose combines to form starch. This belongs to macromolecular colloid. And the third type is associated colloid. Associated colloid. Here, certain substances act as electrolytes. Certain substances act as electrolyte at a lower concentration, but act as colloid at a higher concentration. Certain substances act as electrolyte at a lower concentration, but act as colloids at a higher concentration due to the aggregation of particle. Due to the aggregation of particle, and the aggregated particle thus formed is termed as micellus. Aggregated particle formed is called a micellus. Okay? Micellus means certain substance act as electrolyte at a lower concentration, but at a higher concentration they act as colloids due to the aggregation of particle. The aggregated particle thus formed is called a micellus. And we can study how micellus are formed by taking a familiar example. The minimum concentration required for the formation of micellus is called a critical micellus concentration, simply known as CMC, and corresponding temperature is called Kraft temperature. That is, once more, certain substance act as electrolyte at a lower concentration, but act as colloids at a higher concentration due to the aggregation of certain particle. The aggregated particle thus formed is called a micellus. The minimum concentration required for the formation of micellus is called a critical micellus concentration, and corresponding temperature is called a Kraft temperature. Is called a Kraft temperature. And next we have to study the mechanism of micellus formation. Mechanism of micellus formation. I think you are familiar with the term soap, but some of you are not able to define soap. This is a very familiar term to you, soap. What are soap? What are soaps? Soaps are sodium or potassium salt of higher fatty acid. Sodium or potassium salt of higher fatty acid. Fatty acids means carboxylic acid having higher number of carbon atoms are normally occurs as esters in natural fats. That is called fatty acid. Higher fatty acid example is palmitic acid. Palmitic acid, that is C15H31 COONA. Palmitic acid is COOH. It is replaced by sodium or potassium, then it becomes soap. Or stearic acid. Stearic acid is C17H35 COOH. Sodium or potassium salt of higher fatty acids are called soaps. Soaps are generally represented as RCOONA. RCOONA. This is the representation of soap. Here you can see that this R part is nothing but this hydrocarbon part, isn't it? C17H35 or C15, that is the group containing carbon and hydrogen. They are called hydrocarbon. R stands for hydrocarbon part. Hydrocarbons are hydrophobic in nature. Here COONA, sodium salts. The general representation of soap is RCOONA. In solution, soap dissociate into RCOO minus and Na plus. That is, it splits into anion and cation. Obviously, that Na plus ions goes into the solution. Now we bothered about this anionic part alone. You know, the anion, that is RCOO minus, consists of two parts. The anion consists of two parts. One, that is R. R means hydrophobic hydrocarbon part. Hydrocarbon part, that is R. Next is polar COO minus group. You know, there is an electronegativity difference between carbon and oxygen. Definitely there will be charge separation. That means that group is polar. Polarity arises in that group. Polar CO minus group, which is hydrophilic. In solution, the polar COO minus group move towards the surface of solution. The polar COO minus group move towards the surface of solution, while this R group means hydrophobic hydrocarbon part, is staying away from it. Polar CO minus group present at the surface, while R group is staying away from it. It results in the formation of an anionic cluster or an anionic group. That anionic group is called a miscellus. That is why soap form miscellus in solution. That is, only miscellus are formed by adding soap in water. We normally apply the soap by first applying water and next to soap. Similarly, we remove dirt from the cloth by soaking or immersing the dirty cloth in soap solution. Okay. If you want, I will repeat once more how this micellus is formed. This mechanism of micellus formation, how this micellus are formed. Micellus formation of micellus can be explained by taking soap as an example. Soaps are sodium or potassium salt of higher fatty acid, such as palmitic acid, stearic acid, general representation RCOONA. In solution, they dissociate into RCO minus and Na plus. Anion consists of two parts, hydrophobic hydrocarbon part and polar CO minus group, which is hydrophilic. In solution, the polar CO minus group move towards the surface while R group is staying away from it, which forms an anionic cluster. That anionic cluster is called a micellus. And you have to remember one thing, that soap form micellus in solution. And how does the soap act as a cleansing agent? How does soap remove dirt? That is cleansing action of soap. Cleansing action of soap. Here you can see that dirts usually collect or stick on the oily layer or greasy layer of the fabric or cloth. When this dirty cloth is soaked in water containing soap solution, obviously this soap form micellus in solution. Micellus consists of two parts, R and CO minus. When this dirty cloth is soaked in water containing soap solution, the micellus remains suspended in water, entrapping the dirt particle by attaching the hydrocarbon part to this oil layer and polar end to water. Hydrophobic part to oil layer and polar end to water. So that what happens? As a result, the interfacial tension, the attraction between the dirt and cloth becomes weaker. Dirt is slowly displaced from the surface of cloth and cloth becomes clean. That is the cleansing action. Clear? Dirt usually collects or deposit on the oil layer of the cloth. When the dirty cloth is soaked in water containing soap solution, the micellus formed in water attaching the hydrocarbon part of this micellus attached with this oil layer and polar end to water. As a result, it reduces the interfacial tension between dirt and cloth. Finally, dirt is slowly displaced from the surface of cloth and hence cloth becomes clean. That is the cleansing action. In our body there is an oil layer, sebum. Sebaceous glands secrete an oil that is called a sebum, and it acts as a cleansing agent. By applying soap, it usually helps to remove oil, grease, etc. from our body. Okay, that is the three types of classification of colloid on the basis of different criteria. Once more, colloid is a heterogeneous system that contains dispersed phase and dispersion medium. Particle size is between 1 to 1000 nanometer. Mainly colloids are classified based on the first criteria, that is physical state of dispersed phase and medium. There are 8 groups. Second category based on the affinity or interaction between dispersed phase and medium. And the third one based on the nature of particle. There are 3 groups. Multimolecular. Here the particle of dispersed phase aggregate to form atoms or small molecule within colloidal dimension. In certain cases, the particles of dispersed phase are sufficiently big in size to be of colloidal dimension. They belong to the class of macromolecular colloid. That is, you think about these polymers, macromolecules. Third type is about associated colloid. Certain substance behaves as electrolyte at a lower concentration but act as colloids at a higher concentration due to the aggregation of particles. that aggregated particle formed is called the micellus. There is a minimum concentration required for the formation of micellus, that is called a CMC or critical micellus concentration. The corresponding temperature is called a Kraft temperature. And the mechanism of formation of this micellus or micellus formation can be explained by taking soap as an example. Soaps are sodium or potassium salt of higher fatty acids. It is mainly represented as RCONA. When the soap is dissolved in water, they undergo ionization, which leads to the formation of an anion and a cation. And this anion consists of two parts. One is hydrophobic hydrocarbon part and second one is polar CO- group, that is hydrophilic. This hydrophobic part always attached with the oils and the polar group to water. And when the dirty cloth is soaked in water, this hydrophobic part attached to the oil layer and polar end to water. As a result, the interfacial tension, the force of attraction between dirt and cloth is slowly decreases, so that dirt is slowly displaced from the surface of cloth and hence cloth becomes clean. Okay, that is about the cleansing action. And in the next session or coming session, we discuss about what are the, already citing the difference between lyophobic and lyophobic. We say that lyophobic requires certain special method. And in the coming session, we discuss about that different technique or different methods adopted for the preparation of colloid. Okay, thank you. Thank you.